Good morning, dear students. We were talking about chapter surface chemistry, and I have told you that this chapter is broadly classified into two topics. First one is your adsorption, and second one is your colloids. We have completed each and every part related with colloids. Now, the next remaining topic is your adsorption. Be careful, it is not absorption, it is adsorption. So what is the basic difference between process absorption and process adsorption? To make it clear, let us take a closed container containing water vapors. If anhydrous CaCl2, that is anhydrous calcium chloride, is taken in this closed container, then water vapors will be uniformly distributed in CaCl2. So here we can say that it is a whole body phenomenon because uniform distribution of water vapors are there. So when uniform distribution or whole body phenomenon is there, then the process is called absorption. Calcium chloride or anhydrous calcium chloride, it absorbing water vapors and it becomes hydrous CaCl2. Now, the next is change anhydrous CaCl2 by silica gel. If silica gel is placed in the same container containing water vapor, then in presence of silica gel, water vapor will accumulate over the surface of silica gel. There will be no distribution of water vapors inside the silica gel. No uniform distribution will be there inside the silica gel. The water vapor particles will remain stay on the surface of the silica gel. So when the process is limited to the surface only, then this process is called adsorption. So here we can say that silica gel is absorbing water vapors. So what's the definition? Definition is very simple. The accumulation of molecular species at the surface rather than in the bulk of a solid or liquid is termed adsorption. Here the accumulation of water vapors takes place in the bulk. Here it is not in the bulk, it remains on the surface of silica gel. So this is your adsorption and this is your absorption. So anhydrous calcium chloride absorbs water vapor while silica gel adsorbs water vapor. Water vapor will remain on the surface of silica gel. And remember, it is not uniform. It will be non-uniform. It will be heterogeneous accumulation of water vapors over the silica gel surface. But here it will be your homogeneous distribution of water vapors inside the calcium chloride. Two terms becomes important whenever we talk about adsorption. First one is your adsorbate and second one is your adsorbent. The terms are similar to solute and solvent of true solution. So here silica gel is providing its surface for the accumulation of water vapors. Silica gel is providing a surface for process adsorption. So silica gel becomes adsorbent here. So the species which provides their surface for adsorption are called adsorbent, and water vapor which gets accumulated on the surface becomes adsorbate. So adsorbate plus adsorbent in total gives you adsorption. Adsorbate particles get adsorbed on the surface of adsorbent. Now why the process takes place on the surface only? The reason is very simple. Whenever we talk about silica gel, then the atoms of silica gel, or we can say silicon, present at the surface have some unutilized valencies, and to satisfy this unutilized valency, the adsorbate particles gets adsorbed over the adsorbent surface. So answer is simple. Adsorption takes place due to presence of unutilized valency on the surface of adsorbent. Then comes their classification. Based on the force of attraction between adsorbate and adsorbent, adsorption is classified into two types: physical adsorption and chemical adsorption. It is also called physisorption, it is called chemisorption. In physical adsorption or physisorption, the force which is responsible for adsorption process are weak van der Waals forces. Please remember, van der Waals forces of attraction are the weakest force of attraction. Whenever the forces are weak, they have a long range. They have a long range. The strong forces have a limited range. They have a narrow range always. Please remember. So here, van der Waals forces of attraction are responsible for the adsorption process, or between adsorbent and adsorbate, the force of attraction is van der Waals force of attraction. But here in chemisorption, strong chemical forces are responsible for adsorption process. Whenever adsorbate particles gets adsorbed on the surface of adsorbent, then energy is released because there exists a force of attraction. If the forces are weak, release of energy will be less. If forces are strong, release of energy will be more. So here, energy release is 20 to 40 kilojoule per mole. When 1 mole of adsorbate gets adsorbed on the surface of adsorbent, then the energy release is 20 to 40 kilojoule for 1 mole of adsorption. But here the release of energy is 80 to 240 kilojoule per mole when 1 mole of adsorbate gets adsorbed on the surface of adsorbent. The release of energy lies in the range of 80 to 240 kilojoule. It's a very high range. The value is very high. Reason? Because strong chemical forces are there between adsorbate and adsorbent. Then comes the next point, low temperature. As the force of attraction is weak, if we increase the temperature, then the adsorbate particle will be removed from the surface as the force is weak. That's why we require low temperature here, so that the bond between adsorbate and adsorbent do not undergo cleavage. So low temperature is required, but here high temperature is required. Reason? Here between adsorbate and adsorbent chemical reaction takes place. And every chemical reaction is having some amount of activation energy. If the particles are having activation energy, then only they will be converted into products. So here, high temperature is required. Then comes next point, reversible, it is your irreversible. As the forces are weak, the process is reversible in nature. But here, it is irreversible because chemical reactions are taking place. Once the adsorption has taken place, then it will form the product. So it is your irreversible process. Then comes here next one, non-specific. Weak forces of attraction can be developed between any two species. That's why it is not specific. A strong force of attraction always takes place between a particular species. We cannot select any species for a strong chemical bond. So here adsorbate and adsorbent will be specific. Between the specific species only a strong forces can exist. So here it is very specific. Then comes the next one, multi-molecular layer is formed. I've told you the forces are weak, so they have long range. So wherever the range of van der Waals force of attraction is there, adsorption will take place. More the range, more layer will be adsorbed. So it forms multi-molecular layers. Here, forces are strong, so there is having low range. If adsorbate and adsorbent comes in contact, then only it will give you chemisorption. So definitely we can have only one layer. So here it is monomolecular layers. One layer will be formed. Here more than one layer will be there of adsorbate particles. Then comes the next one, no appreciable activation energy is needed. It's not a chemical reaction, it's simply a process, physical process. So no energy is required. But here chemical reaction is there. So we can say high activation energy is needed. Because energy is needed, that's why this is called activated adsorption. So the differences between physical adsorption and chemical adsorption are important. That's all for today. Thank you. Have a good day.